Okay, everybody. Now we are going to do kind of what we did in the last problem. We're going to set up some equivalent ratios and solve them. We're going to do this though in a different way because not all of these problems can be solved simply with just a couple ratios. Some of them we need to actually do some calculations. So we'll be looking at that. So what you are looking for, right, when you're saying, well, how can I get out of having to do the actual calculations and just kind of do the ratios? Well, you're looking for your special triangles, right? You're looking for your special triangles. Those would be your the two that we discussed were the 45, 45, 90, and then the 30, 60, 90, right? So we're looking for those. And so that's what we've got here, right? We've got one of those and we've got one of those here. So let's do those first, and then we're gonna attack this one, right? Okay, so for this one, right, we got to remember what our ratios are, right? So the general case ratios of this, all right, for a 30, 60, 90, right? The general case ratio is this is x, this is 2x, this is x times the square root of 3, okay? And so you look at what they're asking us to find x, and they're giving us the hypotenuse as well. So what we want to find out is we want to use the cosine, right? We want to use the cosine. And so I know that for this one, when you figure out cosine, right, the cosine of the 30-degree angle, so the cosine of the 30-degree angle, the general case is this x times square root of 3 over 2x, right? So your x's cancel and you're left with square root of 3 over 2, right? Because that goes away and that goes away. So what we want to do now is set up a ratio comparison and solve those. So we have square root of 3 over 2, that's the cosine of the general case, should be an equivalent ratio to this one. And in this case, this is my adjacent and this is my hypotenuse, so it's x over 8, right? And so what we're going to do is we are going to do, I think we should just do cross products with this. All right, so let's do that. And I kind of went over that in the last video. And if you didn't watch that video, then you're going to learn really quickly, because I think this is the smartest way to do that. Cross products, some people call it butterfly. Please don't call it butterfly. It's not a butterfly. But you multiply these two, and you multiply these two, and you set them equal to each other. All right, so you take 8 times the square root of 3, so we're going to go 8 times the square root of 3 is equal to 2 times x. All right, and so now it's just a matter of, well, let's solve for x. Well, all we have to do to solve for x is divide by 2. Okay, and so when we divide by 2, you do that, and you get x is equal to 4 times the square root of 3. And then it says round to the nearest tenth if necessary. So all we got to do is just put 4 times the square root of 3 into a calculator, okay? And so I just happened to pull up a calculator, all right? So we want 4 times the square root of 3, so you're going to go 4 times, and then we're going to hit our square root button. We're going to put 3 in here, and we're going to hit equals. And you get 6.928. And did he say tenth or hundredth? If it's tenth, it's 6.9. If it's hundredth, it's 0.93. And he said tenth. All right, so 9.2. Oh, wait, no, what am I talking about? 6.9. I wasn't even close. 6.9. All right, so about 6.9, all right, and this technically should be the squiggle, right, the approximately, all right, so about 6.9, all right. This one is going to be kind of the same thing, all right. We're gonna be using, remember our relationships on this one for the general case, right, where you have x, and square root of 2, x times the square root of 2. Right? So both your cosine and your sine function, remember, wound up being square root of 2 over 2, right? And so that's the ratio we're going to use. And if you don't remember where we got that, you can always reference this, right? Where you have both of these relationships here. The thing that's nice about this one is I know it's going to be the same thing, right? So it doesn't matter if you use sine or cosine, you know it's going to be square root of 2 over 2. So we're going to use this. So we're going to say 10 over x, which is the relationship here to this. In this case, we're using sine, right? So the sine, right, 10 over x is equal to the sine of 45 degrees. In the general case of that is square root of 2 over 2, right? So that is that we have equivalent ratios, and now we're going to multiply and do some razzle dazzle here. So we're going to do our cross product. So let's multiply these two first. So we're going to have x times the square root of 2 is equal to, and then multiply these guys right here, 10 times 2. All right, so let's simplify. You have x times the square root of 2 is equal to 20. Now we're going to divide both sides by the square root of 2 to get x by itself. And that gives you 20 over the square root of 2. Now, if you were leaving this exact, you would have to rationalize this, move this up, and do some simplifying. But we don't have to do that because we're finding numbers for it, right? We're gonna find a decimal approximation. So I have 20 divided by the square root of 2, so we can go straight to the calculator for that, right? So we go 20 divided by, and then hit your square root button, and then hit 2, and then just hit equal, and you get 14.1 is what we got. So we got 14.1. All right. And so now, have we needed an exact answer, what we would have done is we would have done this. Square root of 2 times square root of 2. You would get 20 times the square root of 2 over 2. And then you would simplify this to get 10 times the square root of 2. All right. Which kind of makes sense if you think about it, because if this is x and this is x times the square root of 2, and this, instead of being x, it's 10, then it should be 10 times the square root of 2, right? So that's kind of 10 times square root of 2 is about 14.1. So that's what you get. So that's how these problems work. We will come back in the next video and we will show you a problem now where you're going to do kind of an entirely different sort of calculating. Okay, so we'll see you in that one.